I'm out in the chaparral today working on my Mercruiser stern drive, 4.5 liter and Alpha1, and my system has always had some issues from the time it was brand new. You know, I'm into what, 4 years old. Doesn't like to come out of reverse. You'll be coming into dock or something and it's slowly moving forward. You drop it in reverse to slow yourself down as you're coming to dock, and then you go back to neutral and it'll hang in gear, and in some cases it hangs in gear and then stalls the engine. The dealer actually looked at it when it was new, but it was just a quick check. They took a quick look at it and said, oh yeah, it looks like it's adjusted okay. It's gotten somewhat better over time, but it's still a problem. So my job today is to kind of dig in and see if I can understand where the trouble is. Let me just give you a little bit of a preface of what steps I'm going to go through. This part of the video, I'm complete and I'm ready to go, and I think I've got it. But things that you'll see in this video: one, when you go to the book, I try to work to the book, but when you go to the book, there are several things you can check. The first one, from a shift adjustment point of view, you have to go in and disconnect the cables. But what you'll test is, you'll test the remote control cable, and you'll test it for lash. Is the remote control cable loose? And so there's a process to measure lash, and there's a process to measure whether the remote control cable goes through its whole span, from reverse to forward, wide open to wide open throttle, both directions. And so if those are out of spec, you're kind of in trouble. Second one is, there's a test for lash of the intermediate cable, the shift cable that goes down to the stern drive from the shift mechanism, I'll call it, up on top of the engine. And again, they're looking for lash, and if everything is good and the lash is within spec, then you should be good. Then there are some adjustments made to the cable length to get the shifts in the right position. And finally, this one is a little harder to dig into, but there is an adjustment for the intermediate shift cable that goes down to the stern drive, and that one's really hard to find in the book. Generally they only give you that number, how to measure that for a new cable if you're replacing the cable. And I found out that the reason why is that it's staked in position from the factory and you can't adjust it. And as I go through here, that caused me a challenge, I'll just put it that way, because mine seems to not be exactly spot on. So in any case, the reason I'm going into this is that it tends to hang just a little bit in reverse, and when you go to neutral, sometimes you have to go past neutral and toward forward to get it to drop all the way out of reverse. And so I'm going to walk through every adjustment there is and try to get this thing solved. And in the end, I think I do have it solved. So, spoiler alert, whatever. That's where I'm going. And if you have one that you need to adjust, these are the processes. And the references as I go through here, this is a 2018 with a 4.5 liter with an Alpha1 drive, Mercruiser. It's a standard right-hand drive, so all of my work is done in that direction. If you happen to have counter-rotating or left-hand drive ones, some of these adjustments are done just a little differently because of the nature of the way the drive rotates. So you have to check those for special instructions. Now, as I launch into this adjustment sequence, I decided I better give you a little extra instruction. The basic construction of a Mercruiser stern drive gear package down in the bottom of the lower unit, the gears have what they call dog clutches. And so when you try to engage a gear forward or reverse, you first push the gear forward, and it may hit on the teeth of the gear, and they have ramps and they have call them notches. But what you do is you push the gear forward, and if it hits on the face of those gear teeth, dog clutch teeth, you won't get engagement, which is why there's a switch that interrupts power so that you don't get what I'll call a clash, right? So you hit face on the teeth, the power interrupts, you rotate them a little bit, and then you drive them on home all the way in until they're fully engaged. And so if you're doing an adjustment procedure, you need to be sure that the lower unit is fully engaged before you make the adjustment, or it won't be right. There are two ways to do that. One is, if you're on the trailer, you have the boat out of the water, you can go down and have two people. You can come up on the top and shift it into gear, or push the lever under the motor cover, and someone down on the bottom can rotate the propeller in the direction that it would normally go, forward or reverse, until you line up those dog clutch teeth. You line up the dog clutch teeth and you push them in, and they're seated. In my case, I have the boat in the water or sitting on a lift, and so nobody can jump in there and turn the propeller. So I'm using the engine to turn the system and engage it just like it normally would. And so you have to make sure the boat can't move. In my case, it's here on the lift, partially lowered into the water. Or you could do it out in open water with a second person. You need to be sure you're not going to go run into somebody or something and damage your boat. So it's up to you to be careful. So what you're going to see in my video here is I'm going to shift things into gear with the engine running so that the dog clutches rotate, push in, and fully seat so that you can make proper cable measurements. If you were doing this out of the water, you follow that same procedure by somebody rotating the propeller while you're pushing the cable into place. And a couple places here I'll make comments about right hand and left hand. I'm working on a right hand drive. If you work on a left hand drive, in some cases you need to rotate the propeller the opposite direction, or you do have to rotate the propeller the opposite direction. And in some cases where I'm working in forward gear, on a counter rotating, you would need to put it in reverse gear instead. And you might have to, if that isn't clear, you might have to consult the book. But as I go through these procedures, places where it says put it in forward and measure, or put it in reverse and measure, if you had an opposite counter-rotating drive, you would need to do the opposite because of the mechanism for the opposite rotation. I know that probably doesn't sound really clear, but it's the way the drives are mechanized and the shift mechanisms operate. So as I go forward here in a few minutes, you're going to see me making measurements where I'm under the motor cover and I'm pushing the shift lever in with the engine idling so that it drops into gear and gets a full engagement of those dog clutches. And it's a little bit challenging, but the ones where you're trying to measure the intermediate cable and its engagement needs to go through that process. And as I get started here today, this is the shift mechanism down this side, and working on it, I'm going to say, is going to be a little bit of a challenge because it's mounted vertically here between the exhaust manifolds and the intake, and so getting down to the switches and getting down to see things is a little bit more of a challenge. I got some wires dressed over the top here that are tied down with tie wrap, and I might even have to break that tie wrap loose in order to get down there, but we'll see. I'm going to try not to. This one says shift anticipate, So that's probably, yeah, that's the switch for the interrupt, which interrupts the ignition when you're coming in and out of gear. And then there's a second one here that's labeled neutral, which is this switch down on the bottom here that I guess is supposed to tell you that you've made it into neutral. And then there's a shift assist assembly. This one looks like, this top one looks like it's the shift cable from the front, from the controls up in the front. This second cable that's in the middle is the shift cable that goes down. See if I can get a good look at it here. That one's the shift cable that goes down to the out drive, all the way down to the bottom. Again, it's just hard to get a good look at it. That one is the throttle cable. And so as I go in here, there are going to be some processes where I'm probably going to need to disconnect the throttle cables and shift cables so that I can run some of the tests. But the last comment is there's this this device here that they call a shift assist assembly. And honestly, I've never had one of those on my engines before, so I'm not quite sure how that works, but it apparently has some kind of a spring mechanism in it, spring or damper, one or the other, that helps you with the shift. And it's important when you're doing the adjustments to know, to understand whether that's there or not, because some of the adjustment techniques are different, whether you have that assist or don't have that assist. My other boat that has a 5-liter small block Chevy on it, the old style Mercruiser V8. It's carbureted and the manifolds sit lower, and so this whole assembly sits up and lays flat, and you can get to everything much more easily. Now, first of all, I've warmed it up just a little. There are some standard procedures for going through this. It says that I need to remove the cable from the shift mechanism and the throttle cables. In the olden days, so to speak, we used to do that with, they had nuts attached to them, and now you have these little cotter key things that are bent over. So I need to unbend that. Probably reuse these guys, but it'd be better to get some fresh ones and replace them with new. But that will let me disconnect the shift assist mechanism. That's the shift assist mechanism. Let's see what that does. Yeah, it's just a big spring. It tries to get you centered up. So I guess it's an assist coming out and a little extra force going in. So I pulled that pin out, so that removes that one. And then there's the shift cable from up front. And down here, there's a little latch. That's the throttle cable, and it has a little latch that is supposed to turn back. Now that little latch has got a pivot on it. The pivot's up here, and then it latches down here on this post. And I think I should just be able to push it and get it to release. There it goes. Just took two hands, or not two hands, 2 fingers. So then that one pushes back out of the way. Again, it's tight clearance. Alright, so then that, I have to turn this back far enough because that little latch is in the way. Once the little latch is out of the way, then the throttle cable will slide right off. So now the forward shifter is disconnected, and all I have left is the intermediate one that goes back to the drive. Alright, what they want you to do is push this in. This one is a little bit hard to show you, so I'm going to try to give you a little extra explanation without the video. You push in first to reverse direction and push the lever in all the way with the engine running. Then shut the engine off so that it'll hold that position. Then what they want you to do is push that lever in until the cam that has the disconnect interrupt switch on it, till that cam starts to move. So you'd push it into reverse, push it all the way until it starts to move, then relax it a little bit and pull just slightly, and to just take the lash. You're just trying to get the lash from the point where the cam starts to move to where you're relaxed. And then you put a mark when it's all the way in with the Sharpie, and then you put a second mark with the lash pulled out the other way. Then you start the engine, shift it into forward gear, the opposite direction, and do the same thing. Pull toward you until that cam starts to move, and then make a mark, and then relax it and go the other way just a little bit, and then make a mark, and that's how you get these lash points. With the engine running, or if you didn't have the engine running, you would do this static. I had to go back and read the static instructions, and it made more sense. But here you have a shift lever, and you have a cable, and that cable goes all the way down to the inside the stern drive. And the question was, how much slack or lash, lost motion is there in the stern drive unit and in the cable? So it needed to be running or held in such a way that you could get there. So the cable's extended and you can see. But what you end up with is, so for reverse I've got two marks on here, and for forward I have 2 marks on here, which is pushing all the way in until the switch starts to move, and then relaxing it and looking at the difference. And the answer, the requirement is to be less than 9/16 of an inch. If you're less than 9/16 of an inch, the design is, the parts are assumed to be good, and you don't have too much lash in the final drive or in the drive unit. 10/32 or 5/16 between the center of the mark to center of the mark. Well, that's plenty good. And I mean, there's really no reason this almost brand new unit should have lash, but it's the process, so we'll check it and make sure, you know. So if I go down to this one, I've got 1, 2, 3, 4, 5. I got 5/16. And the answer is you could have up to 9/16, and the system would be good. So test 1 is passed. I don't have too much lash in the system. One of the things I'd like you to do is check the range of motion of the shifter from the front. Since my issue is coming back to neutral and not whether I get fully engaged, I'm going to skip over that step. What I'm really more worried about is, this is the interrupt switch, and it cuts the power momentarily when you shift into gear, and it's got a plunger on it, and there's an adjustment that should be made. The adjustment amount is supposed to be 1/32 of an inch, and I happen to have a wire that's like 31 thousandths. I have a wire that's about 2 thousandths off of that. It's about a 20 gauge, and I've been trying to sneak that in there, but it doesn't go. That wire should go around. You see, there's the wire and there's the plunger. The wire won't go through. So that suggests I could have an issue here with this timing switch. So it could be adjusted. One of the things they want before I adjust it, there is an electric measurement. I have my ohm meter set up, and I have disconnected the plug from the engine harness, and this is the connection to the switch. Now, you really want to be careful with these because these are engineered connectors, and you got to be careful about, I'll say, stuffing anything in there that could cause an intermittent connection in your connector. So this is going to be kind of difficult, because what I'm going to do is just hold my probes up against it with one hand, and you can kind of hear the, right now it's made, which is why you get a conductive signal. And what I need to do is move this off center until that stops and measure how far it goes. That's probably going to be really challenging because I don't know if I have enough hands. Yeah, the best way to get into a connector like that is to get the correct pin that belongs in there and then stick a couple of those pins in there. If you start sticking things like paper clips and so forth in there, you'll end up with difficulty. Let's see how far we go before it kicks out. Here, if I'm neutralized, that scale is in 16ths. So that's 1, 2, 3, 4. Yeah, that's 16ths. So let's do that again. I think that switch is misadjusted. The requirement is 3/16 plus or minus a 32nd. One, 2, 3/16. 1, 2. Whoop. See, there's 1, 2. Let's make sure we're centered up. 1, 2. See, I'm only getting about 2. If I go the other way, it's close. If anything, it's a little bit to the tight side. I would say it's on the hairy edge of being out of spec. I think I'm going to adjust it slightly, because it could also be a little over 3/16. Let's see if I can't make that more nominal. Sneak in there with a right-angled Phillips here. Okay, now can I get in there? Get my wire in there.
I'm sorry that connector's in your way so you can't see. The wire goes through between the tip of the plunger.
Okay, that's too much.
The tip of the plunger of the switch and the surface of the cam. You just run the wire through there
the wire in
until you get a slight drag on it.
I basically just scooched it back and then put my wire in there and then ran it down until the wire just touches. I'm going to have to turn the camera off and get it out of the way here for a few minutes so I got a little more room to work. Well, I was kind of having a challenge with things, so I went back and got my other test lead kit. I have some other leads that they got little hooks, so they'll hook onto wires, and I have a couple jumper wires that I use for these problems where it looks a little cheesy, but it actually doesn't work too bad. But it's stranded wire, and what I do is gently take as many strands as it takes to slide into the connector, and it doesn't move any metal, it doesn't cause any harm to it. So right now it's making the connection. So now I'm going to come back up here and let's see if we can see if I move this. You can tell when the switch opens by when it gets quiet. It's taken me probably an hour to adjust this switch. It's really, really difficult because it's very hard to get your fingers down in here and to move the switch a little bit and then to try to get these screws with an angled driver. So from here, 1, 2, 3/16, right on it. And up here, 1, 2, 3/16, and it's off. So that's pretty darn good. What I used was just my piece of 20 gauge 32 thousandths wire, and I ran it through here till it's just, I'm just pushing it through the gap until it's got just a slight resistance. But before I couldn't get it through there at all. So let me tighten this down and assemble things back together and see if it makes a difference. Well, I've got some things out of the way. Let me get the throttle cable connected, because that guy's all the way down here. Get my hand in there, sneak that in, snap on the clip. It works just a little easier with the shift cables out of the way. Let me grab these guys down, put the pin back in it. So we got that pin back in there, and they just kind of bend it just kind of bend it over. Well, that still didn't work. It just looks like the shift system is not pulling it all the way back to neutral. So, I'm going to pull this pin back out again, and pull this pin back out again. There is an instruction. I've gone to the engine installation instructions actually, and there is an instruction that says to measure the play, this assembly from one end to the other. So I'm going to get my little Sharpie, which still isn't quite as perfect. It's not as sharp as I would like, but it's as fine point as I get. So the mission here is, it's in neutral up front. So if I pull here, I'll put a mark. And if I push there, there's a mark. And then I'm supposed to go halfway in between, and it's 10/30 seconds, so I need to be about 5/30 seconds. That's the center point right there. Alright, so that's 5/30 seconds. And the instructions say that I should be from that center point. And what they want is 7 3/8 inches with this in the middle. They want 7 3/8 from the center there to the center here. And I would say we're a little short. I mean, it's a little hard to get an exact measurement, but 1/8, 2/8, I'd say we're 1/8 inch short. So I'm going to take that off. And let's see if I can get a closer measurement. And I think I'm going to try to readjust this barrel. And in order to readjust the barrel, you got to take it off anyway. So I'll sneak this, bend this pin straight. Come on. Well, I've gone ahead and put 4 turns on this barrel, which takes this from the middle point, 7 3/8. The confusing part from the boat manual standpoint is it says that this shift assist assembly should have the same center to center distance, and it actually seems to be shorter. This one really is 7 1/4. Yet there's slack in the cable, so I'm going to take a shot at this and see how it assembles. Well, I've put it back together and tried it. I had set the barrel back to extend this further forward by 4 turns, which gave me roughly 1/4 inch. And that caused it to not come out of reverse at all. So I spun it the other way, took the 4 out, put 4 more back in, and gave it 4 turns, 1/4 inch shorter this way, with the slack that is inherent in that cable, I can still put this pin in and the shift assist assembly without any preload on it. And I did an initial try, and it seems like it's coming out of reverse clean. So right now, I ran it, shut it down, and what they want to do is they want to make sure that your that the disconnect intermittent switch is centered, and it is. So right now I'm engine off, wide open throttle, forward gear. I just put it into gear, shut the engine off, and then took it to wide open since I'm sitting at the dock. But that seems to be correct. So now I'm going to go through it in reverse and double check the reverse direction. Now, that wide open throttle reverse. Am I still centered up? And it seems that I am. It's sitting on the springs. Nothing seems to be pushing it. So essentially, we can see the markings. Essentially, there's a recommendation that said to set it for the neutral, and I basically set it for the tighter side so that it would push out just a little bit further. We're going to give that a try and see how it works. Okay, I've compromised the position a little bit, and I moved it back to 2. That's a bad one. I was at 4 and it was working. Now it's at 2 and it's not working, so another adjustment. Alright, I went back to 3 turns. Basically 3 turns of the barrel, extending it a little bit so that when you pull it back out, that it pulls harder out of reverse. And that's not exactly how the book says to do it, but with the variability in the controls and stuff, it seems like that may work. So that's all for now. Alright, this one's a little bit more complicated. What I'm trying to do is check the cable adjustment for the intermediate cable that goes back to the stern drive. The book suggests you should never have to touch it because it's factory adjusted. And you probably shouldn't or wouldn't normally do this with the boat in the water, which is where I am right now. But what I would like to do is at least do a sense check, because I've been having, because of my challenges, and see if it's anywhere close. So what I have done is I fired up the engine, I put it in gear, went to forward gear, which brings this backwards toward forward, so that I know that it's engaged in forward gear, and then I shut it off once I knew I had it fully had it in forward gear, with the shift cable holding it there. So now I've just pulled the pin out, and in the section of the service manual that talks about installing a new cable, a new intermediate cable, they want the cable to be set at 6 inches. So what I'm going to try to do here is get a scale in here and see, with this pushed all the way to the back, where am I set. And this is going to be also going to be a tricky adjustment to check, because now I've gotten to the point where I'm pushing the the shift switch cam. But boy, just looking at that, it would appear to me that it's short about 1/8 of an inch. Now, does that make sense? Well, I'm going to say that I think it does make sense that if the intermediate cable was too short, I was working on adjustments here that were working to move it this way or shorten this up. So if that cable was too short, then this adjustment would have to get shorter to make things work at the same rate. So I think what I'm going to do is I'm going to pull this pin, and I'm going to pull that pin and take this off and get a more exact measurement as to whether it's truly off out of the 6 inches. At the moment, I had already come in here and made a mark that indicated when it was all the way down. So I know where that's supposed to be. That was in an earlier test. Getting this cable out, if I were installing a brand new cable, the instructions for a new cable are to push this backwards lightly, which actually lines up with my mark that I put in here previously, and then adjust this brass barrel to set the length to 6 inches. Now, the factory has apparently set this with crimped it so that it doesn't turn. So it is truly set by the factory. Now, if I take my little calipers here and go to 6 inches, it is not 6 inches center to center. It's short. And that short then has to be made up by the cable that goes up to the shifter, which is what I was doing previously. So I cannot change this without replacing the cable. So that means what I was doing at the upper end was probably right. The only other place you can make an adjustment is down here where the intermediate cable attaches to the bracket. There is a slot and you can change, but that changes actually the travel of the whole cable, which is something that you really don't want to do in most cases. Alright, so the intermediate cable is fixed. There's nothing we can do with it except check it, but you know, it said center to center ought to be 6 inches, and it's about, you know, it's short by, let's see, what does it measure? It's a little awkward here to try to center distance. I'm at about 580, 590, almost 100 thousandths short, which means that my upper shift cable needs to be 100 thousandths off center as well, most likely. One of the procedures in the book is to check the full travel of the cable and remote control unit at the driver's station. And they want you to do it with the stern drive cable, intermediate cable disconnected. So and I have that. I didn't do this earlier because I didn't have that disconnected. So right now, I have the cable set like it originally was set. It's set to its neutral position, so to speak. It's in, I had already marked it for its lash. It's in the middle. If I take the pin out, there's no load on anything, and the controller is in neutral. So the book says if you have this shift assist device, to use it to put the right cable, a load on the cable, and they want it placed in, this is a right-hand drive unit. If it was left-hand, it would be different. But for right-hand drive, you put it in forward gear, wide open throttle. And then the request is to put a mark on the threaded tube. So we'll mark this guy right there, as that is forward. And then, because they want light pressure. If I didn't have this shift assist, they would say put 15 or 20 pounds on it to the back and then measure it there. But apparently the shift assist provides about 15 pounds. So you do that, then you go and put it in the opposite gear for this right-hand drive, normal drive. I'll throw it in reverse and we'll measure the other end. Right there. And we'll make a mark right there. And when you make these marks, I mean, the marks are a little bit wide and they're always a little bit behind so that you can see them. But that looks like where we ought to be. So now the question in the book is to measure the distance between them. And here's my steel scale. So if I measure from one to the other, they want it 3 inches plus or minus 1/8 of an inch. And it is spot on 3 inches. 3 inches is right there. So there's nothing wrong with the remote control. It is exactly correct. And it could be, you know, between 2 7/8 or 3 1/8. It could be 1/8 of an inch either way and it would be fine. So that one passes its test. So now, to kind of finish things up, summary. I know the input cable is correct. This one isn't an issue. The intermediate cable appears to be a little bit short. Now, there's probably a factory tolerance on it, and it may be within tolerance, but it's, you know, it's a 100,000ths, a 1/10 of an inch short. And if it's a 1/10 of an inch short, that would mean that when you're trying to pull things out, that it isn't quite where it ought to be. And I was adjusting this shorter to match the shorter of that so that they lined up. I am going to set this one so that the gear case is in neutral when the shift handle's in neutral. And it needs to be so that there isn't load here on this one. This would be easier if it didn't have the shift assist assembly. This shift assist is just, I think, has a big spring in it. So you pull on it, it's got a spring, you push on it, it's got a spring. So when you get done adjusting, you want to be able to slide the pin in, and you want this one to not be preloaded one way or the other, or it could cause trouble. And right now, things are in the middle. So given the benefit of slack and everything, what I think I need is when I'm coming back, I need this one to be a little bit shorter to match up with the intermediate cable being a little bit shorter, but I can't go so short as that this gets tight. So let's go back to that as long as I'm at it here. So I'm going to take this one off, and just sort of double check. I don't remember. I was going to do 100,000ths. How many threads is that? It's 1, 2, 4 threads. 4 threads is 100,000ths. 4 threads is a 1/10 of an inch. So that would be like 40 threads per inch. I think they said in the book that that's the thread pitch, is one of the, they make them 2 different thread pitches, but that sounds about right. So if I'm off by 4, I'm going to go 1, 2, 3, 4. I'm going to go to that side. And then if I tuck this back in, and tuck this back in, and put the pin in. See, I didn't want to just adjust this blindly without understanding why. Now I think I understand why. So if I can, there, I can slide that in, and there's no load on this assembly. It basically puts me to the forward lash mark on there, which is, you know, roughly 100,000ths, just a little over 100,000ths, and then that is in neutral. That one should be good. I need to reinstall the throttle cable, need to reinstall the intermediate cable and put the pins in. I'm going to do that, and I'll be back and we'll give that a try. Well, that seems to be working. Well, at this stage, I've done my experimenting and it works. what I'm going to do now is follow what they call the official adjustment procedure and see where I ended up. The official procedure says you want to put it in gear, and because I'm in the boat, I can't reach the propeller. I'm going to fire it up and put it in gear and get that forward gear. For a right-hand drive, normal drive unit, you want to go into forward gear for this one. I already fired up the engine, dropped it into gear, took it to the end of its travel. So that's full in. Take off the shift assisted assembly. Okay, what they want is, with this pushed all the way back, with the cable in forward gear, which I don't have it yet. Okay, so the cable in full, wide open forward gear. What they want is for you to adjust it until, with a very light load down there, that you could put the pin in and it would line up. And they make this really kind of tricky. I'm going to have to put the pin in like that. Okay, so now I'm at the end, and I'm definitely too long. 1, 2, 3. I put 4 turns into this thing, so let's line that up, and then it should line up. Ah, perfect, like that. What they want you to do is, with the clevis pin, be able to slide it in just like that. And if you can do that, then they want you to turn this 4 turns away, 4 turns to the back. Oh, there are 2 threads. One's a quarter 40 and the other's a quarter 28. And this one looks like it's a quarter 40. So what you do is, and that's where I had it adjusted actually, by trial and error, is you want 1, 2, 3, 4, with the slack pulled out. Let me go back to that. 1, 2, 3, 4. So when you do that, with the slack pulled out, you can run the clevis pin in. And now I'll go back to my 1, 2, 3, 4. So 4 turns back, with this being held lightly, this being held forward, and then 4 turns on a quarter 40. Then we can pull it back. I can't get the pin in and out without pulling the thing closer to neutral, so let me go back to neutral. And then pull the pin, slip her back in there, put the shift adjuster back, or assister back on there, like so. Now, technically speaking, by the book, if I'm using the shift assist assembly, I shouldn't need to turn that 4 turns. You should just leave it as it is, and the shift assist assembly will take up the difference. So I'm going to do my 4 turns. I'm in neutral and my shift assist assembly is loose. I don't have it preloaded. And the next step is to make sure that the switch down here, that the cam is centered up and not off center, with it in, with it in forward gear, and with the prop turned so that you know that it's all the way down in. I'm going to have to drop it in gear just to prove that, I guess. So hang on a second. So if I take it to wide open throttle now, after it's in gear, turn my light back on. You folks may be wondering about my light, but I have an inverter in here, and every time you fire up the engine and it cranks, the inverter drops out, so I just turn it off. Okay, so we know we're into gear, and we're at wide open throttle, and the shift cam is centered. So if you can look down in there, you know, I've already showed adjusting the switch, but the cam should be centered and not being pushed off center one way or the other. Given my adjustment, given the fact that the factory cable is off a little bit, I'm adjusting a little bit different than the factory would do it. We'll go back to neutral. So that takes care of all the adjustments in getting this thing together. I was a little disappointed to find that my factory cable appears to be not adjusted to factory spec. It was a brand new system. So Mercruiser apparently crimped that guy off. Somebody in the process got it in the wrong spot. But so far I'm able to correct that by biasing things just a few turns, make a little bit of an adjustment improvement. And so things are better. That's good. I'll put everything away and I'll take it out for a run. But that's what it takes to go through the adjustments on one of these Mercruiser Alpha1 shift systems. I hope you enjoyed that video. If so, please subscribe to my channel.